right, I think we're good to go.
Okay, you're live.
Hello there. Welcome to the SLB demo part of the award ceremony. Today we are going to start for the next 40 minutes. We're going to have some SLB members going over some demos. And then after that, we will. Welcome. Sorry about that. Got a neck up. Okay, yeah. Then after that, we will have the Professional Society Awards. They're going to scroll through those, and then at 6 o'clock, the award ceremony will start. So I am Raj. I'm the Vice President of Activities at the Student Leadership Board, and I'm super excited. I'll kind of be walking you guys through all these demos. Our first demonstration today, we have Eleanor, who's going to be showing us a Coke and Mentos demonstration. So Eleanor, take it away.
Hi everyone, my name is Eleanor. Can you guys see me? Hello?
We see a blue screen right now.
Oh, okay. We gotta switch cameras. Can you hear me?
Yeah, we can see you and hear you.
Okay. Hi everyone, my name is Eleanor. Today I will be doing the Coke and Mentos experiment. You guys may have heard of this in school or maybe in even the science fair, but basically what happens is that I'll be dumping some Mentos into a Coke bottle, and many of you guys know what will happen after, but anyway, what I have here is a 1-inch PVC pipe connecting two bottles. One of them is empty, which will be where the explosion goes, and another one is filled with Coke. So once I turn this valve, a bunch of Mentos, which are actually stored inside of this pipe, will be dumped into the Coke. We'll see what happens after. Well, yeah, so I hope you guys saw that explosion. So what happened there was that if you look closely at Mentos, you'll see that there are actually many little rust spots on the Mentos, and that creates lots of surface area for the dissolved gas inside of soda, like Coke, to kind of congregate and form more gas bubbles. And these gas bubbles need to have some place to go, right? So they end up exploding out of the bottle and then coming back to the other side. And that's it. Thanks for watching. Have fun listening to the other experiments. Bye-bye.
Awesome. Thank you so much, Eleanor. That was super awesome. We always like to start off with a reaction. That's definitely a classic, Coke and Mentos. Next up, we have something at a little bit of a different branch of STEM. So we have Adriana, who's going to be talking about tessellations, which is a fun, I'll let her explain it. It's a fun math project.
Okay. Hi, everybody. I'm Adriana, and today I'm going to be talking about tessellations. So basically what tessellations are they look something like this. And they are pieces of art that are very geometrical, which come from geometrical shapes. So think squares and octagons and hexagons. Think those kind of shapes, and you can make them into whatever shape you want and kind of make it into this piece of art. And so if you were to talk about STEAM, it's art, but it's also math. So I'm going to teach you how to make this tessellation right here, and then more of a minimal one for beginners, which looks something like this, and you can design it however you want. So the first thing that I would do is start out by drawing a shape. So for this one, you need to start out by drawing a square, and you can make it just try to make it as equal as possible. And then to make the puzzle piece right here, you're going to have to draw something on top of the square. So you can see, ignore this, but you can see right here is kind of the shape of the puzzle piece that you want to make. And there's no right or wrong way to do this. You can do it however you want. And then you're gonna cut it out. So then you cut the piece that you drew off, and then this is where kind of the math part comes in. So then you're gonna translate it or rotate it or do whatever you want, and you tape the piece that you drew and cut off, you tape it on the bottom. Or if you want to make it sideways like this, you could draw it on the side and then cut it out and translate it here, or rotate it like that. And then it makes a puzzle piece. So then what you're gonna do is on your piece of paper, I'm just gonna show you on here, is on your piece of paper, you're gonna put it however you want, like right here on top, and you're just gonna trace it. And then you keep going all across the page. So as you trace it, then you go here, and then you keep tracing it and making sure that nothing overlaps. And then here, and then it kind of cuts off here, but this one was just really small, but that is like, and then you can color it or do however you want with it. And then for the other side, what I did was I did this, and I kind of cut this part off of the top, but then once it went down, then I added that part in, and then I added this part in. So then you can do whatever designs you want, and then it looks something like that. For the other one, this is a more complicated one, this one, because it comes from an octagon. So what you're gonna do for this one is basically you draw an octagon, and at the same time you're gonna draw like a mini triangle right here, and then cut cut that triangle out. And then, as I said before, once it's cut out, then you translate it down to here, so it makes a heart, as you can see. And then, like, if you want to make it cleaner without all the pen, then here, and make sure that it's taped too. That's really important. And then as you go here, you would trace it right here, and then tessellate it all across the page, so down, across, diagonally. And then, so for this one, this was actually my math project that I did. And you can see it has like clubs and spades in it. I kind of wanted to look like the shapes that you see on card games, on playing cards. So that is like kind of the final product. And there are many different famous examples of tessellations. Like, for example, like on buildings, there's one in London, I forgot what it's called, but there's one in London where there's diamonds and it goes all across it. That's kind of a real life example of a tessellation. And then in beehives, in honeycombs, it's that little I think it's an octagon. It's a little octagon in, and then it goes all the way across, and that's kind of a real life example of a tessellation. So a lot of tessellations are really detailed and stuff, but if you want to make it geometrical or whatever, then this is a perfect place to start. I hope you kind of got a bit of insight on what that is. But yeah, that is tessellations, and I hope you enjoyed the rest of the experiments.
Thank you so much, Adriana. Yeah, I would definitely recommend, like, I was just looking through the other day of tessellations on Google Images. There's definitely some really, some super cool tessellations. And I love that it's not immediately obvious that like it's all just made up of shapes, but you can definitely make some super cool art with just tessellations. So, all right, awesome. Next up, we have Nico. And Nico is going to be showing us, I'll let him explain it. It's pretty cool, but he's going to be showing us a little chemical reaction.
Hello, everyone. I'm Nicholas Usher, and I will be showing you how to pour seemingly nothing out of a cup and extinguish a candle. So right here, I've got a candle with me, and I'm going to use this lighter to light it just like that. So what keeps the fire in this candle burning? Well, there are three things that you need for a fire to burn: oxygen, heat, and fuel. So the oxygen is a gas that can be found in the air, and it's the gas that you breathe in and use for energy. The heat was initially provided by this lighter here. And finally, the fuel is the wick of the candle. So since the flame has all of these three elements, it can continue burning. If one of them is taken away, then it will stop burning. So what we're going to do here, I have this cup and I have vinegar and baking soda. So what I'm going to do is take a little bit of baking soda and place it into the cup there. Let me move this out of the way. And then I have vinegar here, and I'm going to pour some vinegar into the cup and then quickly cover it by this coaster. So here we go. Vinegar goes in, cover it by the coaster, and you can see it's foaming up a lot. And that's because there's a chemical reaction happening inside that is creating carbon dioxide. And carbon dioxide is the gas that you breathe out. And so that's why if you blow on a candle, the candle will go out, because if you breathe out carbon dioxide, it will go onto the candle and replace the oxygen that is around the candle. And since the oxygen is necessary for the candle to burn, and it no longer has that, then it stops burning. So what we can do is take the carbon dioxide from inside this cup, which has been sealed inside here, and I'm going to quickly take the coaster off and pour it over the candle. Here we go. And you can see just like that, the candle is extinguished. So why did this happen? Well, I already told you that there's a chemical reaction inside this cup that creates carbon dioxide. But another thing we should ask is, why, when I pour it out like this, why doesn't the carbon dioxide just float out of here? Well, this is because of density. So if you think of a helium balloon, it is less dense than air, so that will cause it to rise. But carbon dioxide, it's the opposite. It is more dense than air, which means if it's placed into the air, it will sink. So if I pour this over the cup, the carbon dioxide will fall down onto the candle. And like I said before, the carbon dioxide will replace the oxygen around the candle, and therefore it has no more oxygen that it can use to burn, and so the fire will go out. This is quite a cool trick that you can use with just baking soda and vinegar and a candle. And you can use this to impress your friends or your family. Just make sure to not mess with fire too much and to have parent supervision. Thank you.
Super cool experiment, Nico. I love that it's like a take on just a classic baking soda and vinegar experiment, but it's definitely a super cool application. So to everybody who is just joining us, welcome to all of you. And this is the segment of the award ceremony where we are doing demonstrations of science by the Student Leadership Board. And these are all high school students that have volunteered their time and really help out the science fair a lot. And they volunteered to help show some cool science STEM experiments and some demonstrations to you all here. So at 5:40, we will start scrolling through the Professional Society Awards and thank our sponsors. And then at 6 o'clock, the award ceremony will start. All right, without any further ado, the next demonstration that we have is Joy, and Joy is going to be showing us about a strawberry DNA extraction. So Joy, I'll let you take it away.
Thanks, Raj. Congrats to everyone who's participating in Science Fair, first of all. Super cool. And so today, as Raj said, I'm going to be showing you guys the strawberry DNA experiment. So before we get started, I want to define DNA. Most of you guys probably already know, but in case some of you guys don't know, DNA is a molecule that codes cells with genetic instructions used in the development, the division, and the behavior of basically every single type of living organism. Think of like living organisms as in humans, plants, animals, and even viruses. So today, for the strawberry DNA extraction experiment, the reason why we use strawberries is because they're octopolids. And basically, if you think about octagons and the root octo means 8. And in strawberries, they have 8 strands or 8 sets of DNA. we humans only have 2 sets of DNA. So that's something to take into consideration. And the reason why we use strawberries is because of that immense amount of DNA. If I use something that only had 2 sets of DNA, we wouldn't have as strong as a reaction and as cool of the clumps of DNA, basically, as you'll see later in the experiment. So for right now, I have 70% rubbing alcohol chilling in the freezer because it needs to be cold in order for this experiment to work. So now I'm going to show my workstation. So in this bowl, I already got it prepared just to save some time and also for convenience wise. But in this bowl, I have a 1/3 cup of water and a 1/2 tablespoon of salt and also a tablespoon of dish soap in a mixing bowl. And what I'm going to be doing is just kind of explaining the importance of dish soap and kind of a little bit of the reaction as I'm stirring this mixture together. You don't want to stir it too hard or else it'll come up, you'll get like a bunch of bubbles. And even though the alcohol later on in the experiment will get rid of it, you still want to avoid as much bubbles as possible. It won't destroy the experiment or tamper it in any way, but it's just easier to see it without the bubbles. So basically, the way I think about detergent and the way kind of how I was studying this process is detergent is like a snake. It has a head that is attracted to polar water molecules and a tail that is attracted to non-polar water molecules. So I'll start stirring this a little more. And now if I'm now going back to the strawberries have a very similar makeup as well. So within the inner makeup, it has, similar to the detergent, it has a polar and a non-polar lipid layer as well. So I'll just explain kind of the extraction process once I combine the two. But once I finish this mixture, which I just did, you're going to give it one last stir. I'm going to do the messy part of the experiment. So science is always fun when it's messy, but also make sure that you clean up after yourself so you don't get your entire household upset. But what you're going to do is take a Ziploc bag and you're going to want to take 3 tablespoons of the mixture. And you're going to want to place it into the bag, trying not to spill it anywhere. As I said, science is messy, but yeah. All right, so one more, and I spilled a little bit, but you know what? I'll give it one more. All right, so that should basically enough. And now what you want to do is take your 3 strawberries. Note that the stems are cut off. You don't want any leaves in there. But you're going to want to place it into the bag as well. And now you're going to want to crush it. And I will show you. Also, make sure when you put it into the bag, you don't want any air in there or else it's going to pop and you're going to have a huge mess. So I'll move this to the side. And basically what you want to do is just crunch it as much as possible. And as you can see, the more I crunch it, the more kind of juices are going to form. And note that the more you kind of condense it and the more you crush and really like squeeze them, the better DNA will come out of the extraction and the strawberry. So you want to make sure you have as much as possible. So try to get rid of as many chunks. And once again, I'm going to be using a strainer in this experiment too, and that'll also help get rid of a lot of the bigger strawberry chunks. But for the sake of time, it looks like we have enough. Here's kind of what it looks like. It looks like we have enough juices. All you really want is that juice, and it's okay if there's still little strawberry chunks in there. So now what I'm going to do is take this cup. It's a clear cup just so you guys can see it. It doesn't matter what type of cup you use, but if you want to see the reaction and the DNA strands better, it's always good to use a clear cup or some sort of scientific beaker. So now what I'm going to do is pour out this mixture into the strainer so that I get all of the DNA strands from the strawberry mixture. And let's hope that we don't make too much of a mess. There we go. And also, once again, don't worry about the bubbles because the detergent's going to get rid of all of that. But as long as you have the juices in there, that's the main goal. All right, so getting that all in there. And once again, as you can see, it's messy, but what you're going to want to use is like a fork and really push it down as much as you can. All right, so there we go. Yeah, and the more juices, the better because it has more polar lipids to kind of attach to if you put in the detergent. But I'll give it a little mix. Just trying to get as much of the juices in here. All right. That should be enough. Let me get a little more. And the detergent to basically alcohol ratio, as it doesn't really matter when you're putting in the alcohol that you have in the freezer. As long as you have a nice layer of the juices, it should turn out fine. All right, so that looks like it should be enough for now. And you can just throw this. Remember, in science, you don't want to eat stuff. So this has detergent in it, so don't eat any of the science experiment. So I'm going to throw that basically into the fridge, clean up my workstation just so you guys can see it better. But basically in the bottom, we have some of the strawberry juices, and that's all we really need. So now I'm going to take my alcohol, 70% rubbing alcohol, and pour it slowly into the mixture. The slower, the better, because if you shake it up too much, it'll destroy some of the DNA cells in there. So what I'm going to do is just slowly pour some of that into the experiment. And there we go. I can see the DNA strands, but I'm going to wait for some of the bubbles to settle down just so you guys can see it in your own time. All right. Should be good. And I'll hold it up. It'll get clear over time, but if you can see, there's little strands. It might be hard over Zoom, but there's little strands in there that are clear, and it almost looks like jelly. And that is the DNA from the basically from the experiment and from the strawberries. So what happened is the detergent basically, because it's attracted to the strawberry layers within, it attracted to it, and it pulled down all the strawberry makeup and left all the DNA cells on the top, just like how dish soap or any sort of like soap or any sort of material pulls down oils and dirt from like clothes and stuff like that from the dishwasher. All right, so you should be able to see it now, and I'll try to grab some, and then I'll be basically end of the experiment. All right, so one. All right, so you can see there, that is the strawberry DNA. Yeah, so also Raj will paste it into the YouTube chat if he hasn't already, but if you want to do this experiment at home, it is super easy, messy, as I said, but I have the instructions out there for you guys to do it at home, and it's super fun and super cool to see the strawberry DNA. So yeah.
Thanks so much, Joy. Yes, I put that in the YouTube live stream chat. So if you would like to perform that experiment at home, make sure to clean up after yourself, and use all the proportions correctly. But that was super cool. I love that you can like see the DNA, because sometimes it's so abstract, like what is DNA, right? So this is definitely super awesome. Thank you so much, Joy. All right, next up is actually yours truly. It's me. So I will share my screen, and what I'm going to be showing you guys today is, I will actually stop sharing my screen. So what I'm going to show you guys today is a math magic trick. So the math magic trick, what I'll do is I'll kind of perform the trick on you guys, and then tell you why it works. And then I will paste into the Zoom chat how to perform the trick. So that way, if you want to do this on your friends or your family, then you are more than welcome to do that. So, all right, pick any number between 1 and 20. Okay, so you can pick 3, you can pick 20, you can pick any number between 1 and 20. Okay, and then multiply that number by 2. So take that number, multiply it by 2. Okay, and I would write down the original number. So if you have like a piece of paper, write it down. Take the original number, multiply by 2. All right, then add 10 to it. Original number, add 2, or sorry, original number, multiply by 2, and then add 10. Okay, and whatever you have right now, take half of it. All right, and then once you've taken half of it, subtract the original number. So the number that you chose all the way at the beginning, subtract that out. All right, so just to go back through it, pick any number between 1 and 20, then multiply that number by 2, then add 10, take half of what you've got, and then subtract the original number. All right, drum roll please, abracadabra, you're left with 5. You're always gonna be left with 5. If I guessed it correctly, say something in the chat. Yes, it's always going to be 5. And there's actually some cool math behind this. So I would like to show you why this would be true for any number that you choose. So let me share my screen here. And okay, so the reason for this when we don't know a number in math, usually we like to call that number n. So let's just call this number n, some unknown number. So we have a number n, right? And we are going to first multiply that number by 2. So that's the first thing that we did. And then we add 10 to it. Then we take whatever we have and we multiply it by 1/2. So we're going to take 1/2 times all of that. And we have to put that in parentheses, right? Because we have to multiply first, then add, and then we have to multiply all of that by 1/2. So first you multiply, then you add, and then you take all of that and multiply it by 1/2. And then finally, we subtracted out the original number. And what is the original number? Well, the original number that we chose is just n, because we don't know what that number is. It could be any number. We're just going to call it n for now. Okay. And now this expression will always simplify to 5. And the cool thing, the way that to simplify this, because it's not immediately clear, what do you do here? So the way to simplify this is with something called the distributive property. So as a kind of a sidebar, what is the distributive property? So the distributive property is a property where if you have a number being multiplied by things that are added or subtracted in parentheses, then you can use the distributive property. So for instance, if I have like 4 times 3 plus 2, right? I could multiply this out, right? 3 plus 2 is 5, right? And then 4 times 5 is 20, right? But I could also use the distributive property. So what the distributive property says is that I can take 4 and multiply it by 3. And I can also multiply it by 2 and then add those. So 4 times 3 plus 4 times 2. 4 times 3 is 12. 4 times 2 is 8. And then 12 plus 8 is also 20. And this works for every number. You can try it yourself. But for every number, this is the distributive property that when you distribute inside the parentheses, you will always get the same thing. Okay, so this might not be useful when you're doing 4 times 3 plus 2. But when you're doing 1/2 times 2n plus 10, it is definitely useful because you can't add up 2n plus 10. That's not possible to do. But what you can do is take 1/2 and distribute it to 2n and distribute it to 10. So here's what we do. We would have, again, we're going to take 1/2 and multiply it by 2n and multiply it by 10. So we would get 1/2 times 2n plus 1/2 times 10, all subtracted by n. And the epic thing here is that 1/2 times 2 is just 1, right? That's 2 divided by 2, it's 1. So we have 1n, which is just the same as n, right? 1 times n is just n, because 1 times anything is that number, right? And then 1/2 times 10 is 10 divided by 2, which is also 5, right? So n plus 5. And then we're going to subtract out n. And by the commutative property, let's just reorder this a little bit. So we have n minus n plus 5. And we know that any number minus itself is going to be 0, right? If I have 200 and I subtract 200, that's going to always be 0. So n minus n, that's just 0. So we're left with 0 plus 5, which will always be 5. So this is why it doesn't matter what number you choose. It will always be, if you do 2 times that number, add 10, take that, multiply it by 1/2, and then subtract the original number at the end, you will always get 5. It doesn't matter if you choose a negative number, if you choose a very big number, a very small number, a decimal, it doesn't matter. It will always be 5. So this is the math magic trick. I hope that you enjoyed that. Maybe you learned something about the distributive property. All right, next up, we have Jessie, and Jessie is going to be doing a physics experiment with tuning forks and water and resonance. So I'll let her take it away.
Thanks, Raj. So hi, everyone. I'm Jessie, a dedicated member of the SLB, and today I'm going to talk to you about waves. And so I know a lot of us live in San Diego, and we're thinking, hey, maybe like ocean waves. Well, that's not the type of wave that I'm talking about, really. I'm talking about sound waves. So as many of you may know, things like light and sound are really important waves in how we perceive the world. And so today I'm really interested in talking about why it's important to understand how to describe these waves. So there are 2 main things that I want you to be interested in when we're looking at waves. So one is wavelength, so how long your wave is. I hope you can see that. So when a wave goes up and down, right, from one end to another, that is one wavelength, how long the wave is. And how many times that wave goes through one wavelength in a second would be the frequency, or a hertz. So the frequency is how often your wave is moving, or yes, how often your wave would be moving. And then your wavelength would be how long your wave is. And so both of these are really important when describing different types of waves. And so going on to sound, I'm wondering how many of you are really interested in music? Well, today I have some tuning forks. Some of you may have seen these before, but some of you may have not. And so this is an A tuning fork. It only makes a sound at a certain frequency, which is 440 hertz. So I'm gonna bang it now, and you're gonna hear a sound. So just be warned that it's a little bit loud, but okay, I'm gonna do it right now. And so that is an A. And so that's really interesting. What we heard was a sound that is actually a wave. So I know the frequency of A because it's written right here on this tuning fork. But what if I want to know the wavelength? It's not written on here, and there's no way to tell because I can't see any sound waves. They're actually propagations of energy, which is, it's really hard to see with my eyes, right? I can't see that. So what I'm going to do here is an experiment with a closed air column. So what this is this is a tube, right? It's a hollow tube. It's very long, and it is currently an open air column. And then right next to it, here I have a very large graduated cylinder. I believe it's 4 liters. And so here I have it filled up with water, almost to this blue line right here. And so right now this is an open air column. I can blow air through it. It's very open. However, when I put it in this graduated cylinder, the water here will close the air column. And now here I have a closed air column. So there are some really interesting rules when it comes to waves and closed air columns. And so what it is that when I actually put a wave through this air column, there are certain sounds that it'll make depending on how long the air column is. So let's test that out a little bit. Do you guys hear that? I guess it may be hard for you to hear, but there's actually a difference in how the wave will sound at different air column heights. So let's try that again in case you couldn't hear it. So you may be asking, why is that, right? I have this air column here, this closed air column, and all I'm doing is changing the height, but for some reason the sound is different. And so here's the rule. At certain air column lengths, there will be certain fractions of my actual wavelength. So if you imagine I have a wave that's maybe like this long, that's longer than my air column, but maybe at 1/4 of the wavelength, there will actually be what we call resonance, which is when there's an amplification of the noise due to the fact that it's at 1/4 of my whole wavelength. So that's what's happening here. Here, when you hear the first kind of resonance, there's like an increase in sound, and that would be like the first resonance because we're at maybe 1/4 of the wavelength. And so if I go up to larger tuning forks, and with these larger tuning forks actually have a smaller frequency, I will actually have a longer wavelength due to the relationship between frequency and wavelength. So here, this is a C, and I'm going to, actually, I don't know if this column is long enough for that, but I'm going to try and see if I can find the resonance frequency for C. All right, so did you guys hear it maybe right here? So the reason why I keep trying to raise the tube up is because not only does the resonance frequency amplify at 1/4 of the wavelength, but it also amplifies at further fractions of the wavelength. So sometimes you can find the second resonance frequency, I believe at 3/4 of a wavelength. And so sometimes some of these waves are actually pretty long. so I won't be able to find the second one here. But some of them are much shorter, and I will be able to find them. And so I hope you were able to hear all of that. I'm going to test out a few more just so you can hear it better, and hopefully we'll be able to hear some second resonant frequencies. Oh, unfortunately, that's too tall. Or here's A again. I'm going to try F. So I think we were almost there, but see, because this is not quite to a meter, it's a little bit hard to find the second resonance frequency with all of these tuning forks because the waves are a bit long. But that is my demonstration. I hope you were able to hear everything okay. As we still have about 5 minutes to kill, I'm going to do, I guess I will do a short ad for our upcoming workshop. So in addition to being an SLB member, I am also the head of outreach for the SLB. And so this weekend we have our final workshop. You may be asking, what is your final workshop about? We already did the science fair. So it turns out that research is really cool. There are a lot of high school students that do research not only for science fair, but for beyond science fair, for fun. And so what I'm going to be doing with a lot of my other dedicated members of the SLB this weekend is we're going to be doing a small presentation and talk about what it's like to do research as an extracurricular. What is it like to do it outside the science fair and to reach for further goals, such as going to other conferences, as well as looking for research mentors and doing a lot of other cool things, such as like, we even have some people who have some experience with patents. So if you have an engineering project, we will be talking a little bit about that, as well as like publications at local journals. So if you're really interested in research and you would think that, hey, this is really fun, I really want to continue my science fair project and do some more cool things with it, I would highly recommend you come. And yeah, thank you very much for paying attention. I believe we will be starting soon. And yeah, Raj, do you have anything else to say?
Yeah, so thank you so much, Jesse. I would just like to echo that. Definitely do come to the workshop if you're at all interested in continuing your science fair project and continuing your research. The one thing that we always hate to see here at the GSDSEF is you spend all this time working on a project, and then after the award ceremony, nothing else happens. So we really encourage you to continue your research in whatever way, shape, or form that might be. All right. Thank you very much for everybody who presented here, and thanks so much to those who came early to the award ceremony and watched this. I think that is it for the SLB members. Again, I'd like to give so many thanks. Please give some support in the chat for all of the SLB members that presented today. I really want to show them our support and our love for how much effort they put into putting together all these demos, and we really, really, really appreciate it. All right, thank you very much. And the Professional Society Awards and the next segment of the award ceremony will start soon.
here we go, DRS node thing. Let's
Good evening and welcome to this year's virtual Greater San Diego Science and Engineering Fair Awards ceremony. I am Steve Rodecker, the Fair Director of the GSDSEF. I would like to get our show started this evening with a short video featuring Shannon Pope of Sony, one of our sponsors this year, with some words of inspiration about science and engineering.
Science was always my favorite subject, and I entered many science fairs back in my school days. Hi, my name is Shannon Pope. I'm the Director of Product Management with Sony Electronics Automotive Entertainment Solutions business, and I'm also the chair of our President's Diversity Office. My passion for science and technology led me to study electrical engineering in college, which opened the door to a career as an application engineer. My path from application engineer to program management to director has been quite interesting and has introduced opportunities to advance my knowledge of the business to include finance, quality, manufacturing, and marketing. And along the way, I found ways to use and benefit from my technical background. On the business side, we focus on in-car entertainment and infotainment, working with the automotive manufacturers to design in Sony's audio technologies. Not only hardware such as amplifiers and speakers, but also software and coding. We use some very cool audio algorithms. And as I speak with chief technology officers, vice presidents, chief engineers, and other senior leaders in the industry, it definitely helps to have an understanding of not only what the technologies are, but how they are designed to integrate into an overall automotive system. And diversity is a core value of Sony. As chair of the President's Diversity Office, I work with our leadership to ensure that diversity, equity, and inclusion remain key components in all that we do with our team, our business, our customers, and our community. I found that I'm able to apply my analytical and problem-solving skills to my role in the PDO, using data to help create new and innovative programs and initiatives. Having a company culture that is diverse and where everyone feels like they belong is not only good for employees, but it's also good for business. And Sony is always looking for diverse talent, which not only means ethnic diversity, but also gender diversity and cognitive diversity. We know that having employees with diverse backgrounds and experience will make us stronger as a company. So while we have many engineers on staff who work on the technology and hardware of our products, we also have a lot of creative artists who help bring our products to life. Sony's purpose is to fill the world with emotion through the power of creativity and technology. And we are dedicated to supporting future innovators like all of you. And I'd like to congratulate all of the participants in the Greater San Diego Science and Engineering Fair for your ingenuity, innovation, and perseverance in getting here, and hope that you continue on a path where you can continue to impact the world through your curiosity and creativity. Science was.
And thank you to Shannon Pope and Sony for those words of inspiration. Again, it is my pleasure to welcome you to our 67th annual and this year virtual GSDSEF Awards ceremony for 2021. I will be joined this evening by Dr. Earl Williams, who will be presenting and reading award winners' names later in the program. Coordinating our ceremony this evening will be Sam Ferguson, whose voice you may hear during the ceremony. We wish to recognize all of the sponsors who have contributed to making the fair possible and successful this year. So, their logos appear on the GSDSEF website homepage and were scrolled this evening before the show. And now, ladies and gentlemen, a very important announcement. At any point in the show, use the YouTube chat box to show your appreciation. It is located in the chat box on the right side of your presentation screen. Since 1954, the Greater San Diego Science and Engineering Fair has provided an inspiring experience in science and engineering for thousands of San Diego and Imperial County students. You are all part of an unbroken 67-year legacy promoting excellence in science and engineering education, and you can be justifiably proud of your achievements to be selected to showcase your research in this competition, one of the best in the nation. This year in particular, you have overcome many unique challenges as you worked on your projects, and we congratulate you more so for it. Many of you here today will become the scientists, engineers, and computer scientists of tomorrow, helping to maintain a world-renowned San Diego scientific and engineering community. Equally important, all of you will contribute to the goal of developing a scientifically literate population. Now, more than ever, this is crucial to our well-being as a nation. In this unprecedented year, the GSDSEF Management Committee deserves special recognition. In a typical year, each of the 25 Management Committee members puts in dozens of hours of work to ensure a successful fair experience. But this year, because of the planning necessary to produce a virtual fair, that number of hours rose significantly. The GSDSEF Management Committee members met the challenge, and the product was a successful virtual experience that permitted all students to showcase their science and engineering talents. 2 Management Committee members in particular deserve mention because of the enormous number of hours they spent planning, designing, meeting about, testing, debugging many times over, and retesting the judging interview experience to ensure it ran successfully for students and judges. Without the extraordinary input of time and talent on the part of Dr. Earl Williams and Vicki Driver, the virtual GSDSEF would not have taken place. We all owe them both a huge debt of gratitude. Please, at this point, use the chat box in YouTube to show your appreciation. Thank you. Among the most important people in the entire science fair experience are the teachers, who devote huge amounts of time, talent, and energy to helping their students develop and present projects. This year in particular, they faced many challenges and still were able to mentor your projects. We salute your commitment to project-based STEM learning. Students, again, in your YouTube chat box, show your appreciation. Parents, we know this could not happen without you either. For months, you have put up with Home Depot trips, strange smells, and weird devices being constructed in your garages. This year, more than ever. Students, again, in your YouTube, use the chat box to show your appreciation. I would now like to introduce Daniel Schumann of Becton Dickinson and Company, also known as BD. He is the Vice President, Global Operations at BD, and will give a brief keynote talk this evening. Mr. Schumann, over to you, please.
Okay, let me share my screen. One moment, please. On here. Good job of that. The screen. Yeah, there. Screen 2. Okay. Can you see? I hope you can. So first of all, it's a great honor to be able to speak to all of you here at the at our virtual Science and Engineering Fair here in Greater San Diego. One thing you should know is that generally speaking, in corporate presentations, I'm not allowed to use some of the fun parts of PowerPoint. So I'm going to do that tonight, though. So I hope you'll work with me. So that's one of the fun animations. So let me start by telling you a little bit about BD.
Pardon to interrupt, Dr. Schumann. Your slides are not showing.
They are not. You're right. Let me try that again. No, and all that animation.
There we go. Perfect. Thank you.
Let's try. Well, I'm going to go back because there was some good animation we just missed. Let's see. There it is. Okay. Let's try that again. Thank you for letting me know. So anyway, let me tell you a little bit about BD, just for starters. We're a global medical technology company. We have about over 3,000 people here in San Diego. Company is over 120 some years old, about a $17 billion company, big company. And we serve I read that we serve 190 companies around the world. And I asked Alexa how many countries there are in the world, and she said 197. So I guess that's pretty much the whole world that we serve. Oh no, now she's talking. 70,000 employees around the world. Anyway, so here's some of the many things that we, pardon me one moment. I said her name. And so anyway, let's keep going. So this is, hold on one moment, please. Really a bit problem. There we go. I'm back. I just unplugged the website. Shouldn't say her name when she's listening. So anyway, 90% of patients that go into a hospital are touched one way or another by a beauty product. So if you have not heard of us, that probably means you haven't been very sick, which is good. But if you're a brave soul like me in that photo, you might just get immunized by one of our billion or so needles that we've made for the COVID vaccination campaign. Anyway, let's move on. Here's another fun animation. So why science and engineering? You may wonder, okay, you could have any sort of fair. Why did we focus on science and engineering? And really, science is all about expanding human knowledge, and engineering is all about harnessing science to improve our world. So then I have a math problem for you. I know that you're probably all tired of math, but it'll be in a minute. Let's learn about think about a few great scientists just for a moment. So who knows who this is? Well, all right, I can't see your hands, but it's Isaac Newton, right? Hard to talk about great scientists if you don't mention him. Laid down the groundwork of modern physics, invented calculus, and also had some great hair or a great wig. Here's Marie Curie. Did some great research in radioactivity. First woman to win a Nobel Prize, then the first woman to win 2 Nobel Prizes, and the first person to win 2 Nobel Prizes in different fields, physics and chemistry. Pretty impressive. Here you see Rachel Carlson did some really fundamental work. She's a marine biologist and helped shed some light on what we were doing to our environment back in the 1960s and helped start the environmental movement. Mario Molina, a Mexican-American scientist, chemist who won the Nobel Prize along with his collaborators on the work he did to look at what chlorofluorocarbons are doing to the ozone layer. Pretty interesting stuff. And here's David Ho, a real trailblazer in the AIDS research field. Another pretty amazing person. Now let's learn about a couple engineers quickly. And I'm an engineer, so this is a fun part for me. Who knows what Josephine Cochrane did? My sons, Robbie and Alex, complain about loading the dishwasher every day, but if it weren't for her, we wouldn't even have a dishwasher. She invented a dishwasher over 100 years ago. And if you own a KitchenAid dishwasher, well, that's the company she started over 100 years ago. Marty Cooper lives in Del Mar, another interesting engineer. About 40 years ago, he invented the cell phone. So kids, if you like your cell phones, think about that engineer who helped make it happen. Here's Jerry Lawson, another great engineer, a pioneer in the field of video games. Developed a game called Demolition Derby in his garage back in the 70s and designed one of the first video game consoles. So if you like your Xbox, think about Jerry. And here's one of my favorites, Swati Mohan, who I didn't know about at all until a few weeks ago when I heard her voice narrating the descent of the latest Mars rover onto the planet of Mars. And she led the Attitude Control System group and had the honor of narrating the descent of that. And if you have not seen that, go to nasa.gov and look at the video of the Mars rover being lowered from a drone onto the surface of Mars. It's really amazing. There's a camera looking down and a camera looking up, and you can watch it all from your living room. It's really pretty amazing. So anyway, so let's go back to that math problem, science and engineering, which is sort of the theme of this fair. So when you have science plus engineering, what do you get? Anyone? It's progress. It's really that science and engineering are what drives progress in our world. And so, when you think about some of these scientists and engineers, a few of whom we talked about tonight, but the thousands and thousands around the world who have over time been driving progress, the next person you should think about is yourself. And through the work you've done to participate in the Greater San Diego Science and Engineering Fair, you've taken the first steps into joining this distinguished group of people who drive progress. And I congratulate you and I thank you. And if you have any questions, that's my email. Thanks, and back to you, Steve.
And thank you, Mr. Schuman, and a big thank you to BD as well. Mr. Schuman will be presenting their awards later in the show, so you'll have a chance to see him again later. So, ladies and gentlemen, at this point, again, in your YouTube, and your chat box. Show your appreciation for BD and Mr. Schumann. Thank you. And now, I would like to have Dr. Williams explain tonight's procedures. But first, a little about Dr. Williams. As you heard earlier, it was due in large part to Dr. Williams' diligence and tech capability that we had the fair this year at all. But please know this also. He competed in the Greater San Diego Science and Engineering Fair in the early 1980s, where he won first places and a second alternate and third alternate sweepstakes. One of his special awards was a trip to New Zealand. Today, he is a scientist and project manager for the US Navy. As with many GSDSEF participants, Dr. Williams recognizes his GSDSEF experience as motivating him to pursue a career in science. Dr. Williams, please.
Thank you so much, Steve. And let me give you a quick review, everyone, of our awards program tonight. The Greater San Diego Science and Engineering Fair gives many awards. And I'll start my video there. Thank you. So we give many awards each year from a variety of sources, including over 30 professional societies. The winners of these awards were scrolled tonight before the show and are listed on the Greater San Diego Science and Engineering Fair website. We also give numerous regional awards, which are made available to our fair through our affiliation with the Intel International Science and Engineering Fair for grades 9 through 12. Winners will be receiving notification of these awards as well. Now let us recognize the winners of our Professional Society Awards, which were scrolling before the awards ceremony. Use the YouTube chat box for appreciation. And now a quick reminder, all Professional Society Award winners will be sent information about their awards by the professional society which gave them the award. And back to you, Steve.
And thank you, Dr. Williams. Now, students, before we begin presenting our awards, here are a few instructions. If you ordered a t-shirt, it will be sent to you over the next few weeks. I want to remind you that the showcase in Z-Fairs is available for viewing, and the awards will be posted on the GSDSEF website as well, starting here very quickly, probably over this weekend. Finally, ladies and gentlemen, all awards will be sent to you through the mail starting in a couple of weeks. Be patient. It's a lot of t-shirts and a lot of awards. Thank you. Now, on to our first special awards, Advancing the World of Health Awards, presented by Daniel Schumann of BD. And Mr. Schumann, please.
All right, thanks, Steve. So it's my pleasure to announce the awards from BD this year at the GSDSEF. These awards go to students whose projects represent exemplary work focused on topics related to medical science and technology in accordance with BD's mission of advancing the world of health. So we'll start now with the BD Junior Division third place and an award of $200. Shall I just start reading the names, or was there going to be visual? The winner of the first award is Kate Ju of Oak Valley Middle School. There you see it on the screen. Congratulations, Kate. Next is the BD Junior Division second place award of $500 going to Sanvi Dogra of Oak Valley Middle School. Oak Valley is having a strong performance today. Next award is the BD Junior Division first place award and an award of $1,000 to Leanne Fan of Mesa Verde Middle School. Excellent work. Now moving on to the Senior Division, third place and an award of $200 goes to Danya Hussein of Bright Horizons Academy. Congratulations. Next is the Senior Division second place and an award of $500 goes to Haya Belbasi of Bright Horizons Academy. Congratulations. And the final award, the BD Senior Division first place and an award of $1,000 goes to Eleanor Jung of Mount Carmel High School. Congratulations, Eleanor, and congratulations to all our winners. Thank you so much, and back to you, Steve.
And Mr. Schumann, Thank you, and BD, again, for your continuous and generous support of the GSDSEF through the years. Thank you.
Our pleasure.
Now, continuing with special awards will be our Student Leadership Board, and here to introduce the SLB is Dr. Williams. Dr. Williams.
Thank you, Steve. Our fair has an honor society, the Student Leadership Board, the SLB, which is made up of students recognized for academic excellence and contributions to this fair and their community. I would now like to introduce Emily Tianchi, the president of this year's SLB. And by the way, many of our SLB officers and members have projects in this year's fair. She would like to say a few words to our students and present this year's SLB awards via video. So over to Emily's video.
Hi everyone, my name is Emily Tianchi and I am the president of the Greater San Diego Science and Engineering Fair Student Leadership Board. This is my 5th year involved with the science fair and I am a senior from the Cambridge School. My very first GSDSEF in the 8th grade was quite the experience. Not only did I print the title of my project incorrectly on my poster board, dozens of ants ate my lunch before I did. But what I remember far clearer than the accidents is reveling in the creative, curious energy of the scientific community. I talked to at least 20 supportive and encouraging judges and came home with so many new ideas. I completely did not anticipate that I would win a grand award, go on to compete in the Broadcom Masters Finals and Intel ISEF, and dedicate hundreds more hours to researching water scarcity. I've met some of my closest friends at science fairs and cherished my favorite memories at post-judging dance parties and geeking out over super cool science with enthusiastic judges. What I've learned is discovery takes both the brain and the heart. Because what is science without a purpose and a drive to help others? Whether you're researching algal blooms, heavy metals, or orphan diseases, all of you are changing the world one question at a time. It takes great initiative and perseverance to develop a research project, and you've made it. The Student Leadership Board represents the spirit as the honor society of the GSDSEF. This year, we hosted 6 workshops for students, organized a peer mentorship program, started a weekly Saturday Scientist Spotlight series, hosted Virtual Family Day, organized a t-shirt design competition, and initiated our YouTube channel. We accomplished a lot in the middle of the pandemic, so I would like to give a special thank you to our 30 SLB members and 4 other officers, Jesse Gan, Raj Pavari, Aaron Huang, and Nadine Morsi. We also judged the SLB Award, which honors 2 resourceful and fresh projects. Our 2021 Junior Division winner assessed a highly relevant topic. With the project, Does News Affect the Mood and Stress of Adults? Great job to Rebecca Lehman from Swallow San Diego Hebrew Day School. Our Senior Division awardee is working at the intersection of environmental and computer science. Congratulations to Ayush Agrawal from Canyon Crest Academy with early warning detection of arsenic contamination from hyperspectral remote sensing and deep learning and application to Asia. In closing, I hope that all of you will come back next year with more brilliant ideas. Astronomer Carl Sagan once said, "Somewhere something incredible is waiting to be known." Go out and find it. Thank you.
And again, ladies and gentlemen, the SLB Honor Society Award in the Junior Division went to Rebecca Lehman from Swallow San Diego Hebrew Day School. And in the Senior Division, the SLB Honor Society Award went to Ayush Agrawal from Canyon Crest Academy. And now we are pleased to present this year's Arthur Friedman Memorial Teacher of the Year Awards. The GSDSEF gives special thanks for the generosity of Barbara Friedman in the memory of Arthur Friedman, a longtime fair judge and ardent supporter of students and their teachers. This award is given to 1 junior and 1 senior division teacher. The winners will each receive a plaque and $1,000. The winner of the Arthur Friedman GSDSEF Teacher of the Year in the Junior Division is June Poling. Congratulations to June. The winner of the Arthur Friedman GSDSEF Teacher of the Year in the Senior Division is Mi Na Ingram from Westview High School. Congratulations to you as well, and congratulations to our winner. They are truly dedicated professionals, especially this year. Thank you to our teacher winners, and Earl, back over to you.
All right, so now we have 4 awards given by the Professional Engineers in California Government. This is the 12th year for a PECG award at our fair, and the GSDSEF thanks PECG for its ongoing support. Representing the PECG tonight is Diane Vermeulen, Caltrans Acting Branch Chief for Environmental Engineering and a GSDSEF Management Committee member. Over to you, Diane.
Diane, if you are with us, which I do see, if you would not mind unmuting yourself, please. Thank you.
I'm so sorry. Can everyone hear me now?
Yep, we can hear you.
Okay, good evening, everyone. The PEG Awards tonight include $500, 2 $500 scholarships, and 2 $1,000 awards. The $500 winners in the junior division are Issa Tim from the Children's School and Aditya Bisen from Solana Ranch Elementary School. And please forgive me if I mispronounce your names. Next, the $1,000 winners in the senior division are Kyle Tianxi from the Cambridge School and Bella Rose Schmermer from University High School. Congratulations to all of our winners, and thank you.
And now, ladies and gentlemen, I'd like to announce a new award for this year, the Broadcom Coding with Commitment Award, given to a 6th through 8th grade student whose project involved coding to solve a community problem. This year's Broadcom Coding with Commitment Award winner is Neha Bhatt from Carvel Valley Middle School. Congratulations to her. And now we present a special award in the memory of a longtime management committee member, screener, and judge, Ron Mickelson, called the Mickey Award. And it is a check for $100. It is presented tonight to one junior division project, which we feel best expresses Mr. Mickelson's passion for sports, science, and students. This year's winner of the Mickey Award is Gabriel Vanya from De Portola Middle School. Congratulations to him. And now we move to the Red Award, which stands for Ronald E. Dome. And it is presented in the memory of another longtime GSDSEF volunteer and computer guru by the name of Ron Dome. The Red Award winner for this year is Ayush Nayak from Westview High School. Congratulations. And now, representing Collins Aerospace tonight is Jeff Anderson, the Director of R&D Aerostructures. Over to you, Mr. Anderson, please.
Thanks, Steve. Good evening, everyone. As the Director of Research and Technology at Collins Aerostructures here in San Diego, it's our honor and privilege to be with you tonight. The Fred Rohr Science Award has been part of this ceremony for as long as the fair has been in existence, 67 years to be exact. It honors the memory of Fred H. Rohr, formerly president and chairman of the Board of Rohr Industries in Chula Vista, which is now Collins Aerospace. And this award focuses on innovative projects with outstanding contributions in science and engineering that have potential to impact the aerospace field. And this year, the award is given to a senior project and includes a plaque as well as a check for $2,000. Without further ado, the winner of the 2021 Fred H. Rohr Science Award is Michael Zhang from the Bishop School. So congratulations to Michael. His project name was a versatile autonomous mobile robotic platform for agility-centered and human servicing applications. And we saw that as having real potential from a robotic perspective, helping in the manufacturing area. So congratulations again, Michael. The facilitators of the Greater San Diego Science and Engineering Fair will be contacting you to coordinate receipt of the award. Once again, it's our honor and privilege to be part of the extraordinary Greater San Diego Science and Engineering Fair. We greatly appreciate the effort of all the students who have participated and look forward to working with you in the future. Steve, back over to you.
And thank you very much, Mr. Anderson, and thank you, Collins Aerospace, for your generosity here. Our next award is the Reuben H. Fleet Memorial Award, and to present the Reuben H. Fleet Memorial Award, Dr. Williams, please.
Thank you, Steve. The Reuben H. Fleet Memorial Award honors the memory of Mr. Fleet and is a check in the amount of $500 given by the Fleet Science Center. This money is to be used for the winner's college education. And the winner of the Reuben H. Fleet Memorial Award this year is James Ho from the Bishop School. Congratulations, James, and thank you, Fleet Science Center. Back to you, Steve.
And thank you, Dr. Williams. Representing the San Diego Zoo Wildlife Alliance, we have Jamie Feinstein to present 2 special awards from them. So please, Jamie, go ahead and take it away, please.
Thank you very much. Hi, everyone. The San Diego Zoo Wildlife Alliance is presenting 2 awards today, one in the junior division and one in the senior division. Both of those winners will receive a $500 scholarship and a 1-year membership to the San Diego Zoo Wildlife Alliance, as well as a private inside look tour for them and 5 guests. We were excited to find projects that support our mission and vision of creating a world where all life would thrive. Our junior division award winner is Neha Bhatt. And again, I also say, if I apologize if I mispronounce your name, from Carmel Valley Middle School. Congratulations, Neha. And our senior division award winner is Kara Fawn from Westview High School. Congratulations, Kara.
And congratulations to these students, and thank you, Jamie Feinstein and the San Diego Zoo Wildlife Alliance. That concludes the special awards, and now to the category awards. There are 16 categories in the junior division and 15 in the senior division. The winners of the awards in these categories will be announced in this order: 3rd place junior division, 3rd place senior division, 2nd place junior, 2nd place senior, 1st place junior, 1st place senior. A special note now for 1st place award winners in grades 6, 7, and 8. Check the category award slides tonight to see if you have been nominated for Broadcom Masters or are eligible for the California Science and Engineering Fair. The list of Broadcom Masters nominated and California Science and Engineering Fair eligible students will also be listed on our website starting tomorrow. Remember that the category awards are not, repeat, not the final awards given. Following them will be the Grand Award runners-up and Grand Awards in both junior and senior division. And now, Dr. Williams, the microphone is yours again.
All right, so you should be seeing the category awards slide now. Thank you very much. And let's proceed with our category award winners tonight. So we're going to start out in the with the 3rd awards, as Steve said, and in the junior division. And the first category that we will announce the awards in is Animal Sciences. So let's get started. 3rd award in Animal Sciences in the junior division goes to Sarah Alari and Scout Cross from City Tree Christian School, 6 to 8. Next, Victoria Steele from St. Michael's School, Poway. Next, in Behavioral and Social Sciences, Selma Al-Rahib from Nativity School. Sophia Leffridge from City Tree Christian School, 6 to 8. William Norberg from St. Michael's School, Poway. Jake Odenthal from St. John's School, Encinitas. Anissa Portamore, Nativity School. Alexandra Zuna, Nativity School. Next, the third division junior awards in chemistry. We have Maya Delgado from Bonita Vista Middle School. Tori Graham and Grace Rowan from St. Gregory the Great Catholic School. Kai Kinsley from St. Gregory the Great Catholic School. Miriam Soto from St. Peter the Apostle Catholic School. Jackson Sparks from St. Michael's School, Poway. And on to computer science. John Conlon, St. Peter the Apostle Catholic School. Christopher Lara, St. John of the Cross Catholic School. Christopher Nguyen, St. John's School, Encinitas. Ace Pasquale, St. Gregory the Great Catholic School. And on to consumer sciences and product testing. Third division, or third awards in junior division. Bryn Carroll and Claudia Tan from St. Michael's School, Poway. And in earth and planetary science, Nadav Aron, Swal San Diego Hebrew Day School. John Grundalski, St. Michael's School, Poway. In engineering, electrical and mechanical category, Gila Horn, Swal San Diego Hebrew Day School. Spencer Todd, St. Michael's School, Poway. And on to engineering, energy, and transport. We have Brendan Murphy and Robert Schumann from St. Gregory the Great Catholic School. Luke Parker from St. Gregory the Great Catholic School. Caitlin Ragas from St. Gregory the Great Catholic School. And Sawyer Vandenberg from Nativity School. On to engineering in materials and bioengineering. The third awards in junior division are Parker Cresswell, St. Michael's School in Poway. Eduardo Dujuich from Swal San Diego Hebrew Day School. Kaihan Sadr, the Children's School. And on to environmental sciences and management. Abigail Alcala from St. Michael's School, Poway. Leah Barnes from Chula Vista Middle School. Natalie Barrera from Chula Vista Middle School. Samantha Gaylor from St. Michael's School, Poway. Andrew Honecker from City Tree Christian School, 6 to 8. Vincent Johnson from City Tree Christian School, 6 to 8. Addison Solomon from St. Gregory the Great Catholic School. And on to medicine and health sciences. Luke Estrada and Brett Fan from St. Michael's School, Poway. Hannah Horry from St. Gregory the Great Catholic School. In microbiology, we have Kaylee Alice from St. Peter the Apostle Catholic School. Simon Cohen from Swal San Diego Hebrew Day School. David Ellis from Swal San Diego Hebrew Day School. Chloe Thomas from St. Peter the Apostle Catholic School. And in physics and astronomy, we have America Ceja from Chula Vista Middle School. Rhiannon Huntington from Farb Middle School. Richard Korn from St. Gregory the Great Catholic School. Gabriel Vanya from De Portola Middle School. And on to plant sciences. Katie Bailey from St. Gregory the Great Catholic School. Eliana Hastings from Swal San Diego Hebrew Day School. Fatima Mendoza from St. Peter the Apostle Catholic School. Francesca Tarito and Avery Wall from St. Michael's School, Poway. And that concludes the third division awards in the junior division. So we'll move on to the third awards in the senior division, starting with behavioral and social sciences. Angela Guevara from Central Union High School. Priscilla Munoz from Central Union High School. In biochemistry, we have Sonakshi Bala from Del Norte High School. Emily Givens from Canyon Crest Academy. In computer science, we have Mohammed Khan from Bright Horizon Academy, 9 to 12. In engineering, electrical and mechanical, we have Isa Al-Wazir from Bright Horizon Academy, 9 to 12. In engineering, materials and bioengineering, we have Ryan Gion from Westview High School. In environmental sciences and management, we have Catherine DeMaggio and Leah Nepomuceno from Scripps Ranch High School. Eduardo Sanchez from Bonita Vista High School. In medicine and health sciences, we have Haya Belbeze from Bright Horizon Academy, 9 to 12. Rishi Chiniga from Francis Parker School. Ivan Lee from Canyon Crest Academy. Elita Yang from Pacific Ridge High School. Congratulations to all of our third award winners. Make sure to express your yay in the YouTube chat box there, and we will move to our second award winners. Again, starting with junior division and in the animal sciences category. Lily Dant from St. Michael's School, Poway. Kiara Conan from Classical Academy Middle School. Julieta Mansour from Swall San Diego Hebrew Day School. Amalia Rosenberg from Swall San Diego Hebrew Day School. In behavioral and social sciences, Reagan Balul from St. Michael's School, Poway. Elizabeth Cabrera from Nativity School. Julia Castellanos from St. John's School, Encinitas. Evan Dodds from St. John's School, Encinitas. Sophia Durazo from Nazareth School. Sophia Frank from St. John's School, Encinitas. Hannah Lowy from San Diego Jewish Academy, 7 to 8. Grace Marmolejo from St. Francis of Assisi. Angelina Sroor from Nazareth School. Yael Weiser from Swall San Diego Hebrew Day School. Ava Zamora from St. Michael's School, Poway. Moving to biochemistry, we have Sophie Lawler-Eyre from St. Peter the Apostle Catholic School. Roya Ostadan from Nativity School. In chemistry, Aurelia Birdsell from City Tree Christian School, 6 to 8. Kayla Scott from San Diego Jewish Academy, 7 to 8. In computer science, Raymond Flores Jr. from St. Michael's School, Poway. Eva Austin from Coastal Academy. In consumer science and product testing, Cameron Ceresia from St. Gregory the Great Catholic School. Bailey Chevron and Michaela Kinnear from St. Michael's School, Poway. Jessica Greenstein from the Children's School. Yaron Malka from Swall San Diego Hebrew Day School. Luz Olivia May from Nazareth School. Martina Mirabal from St. Michael's School, Poway. Kate Terry from St. Michael's School, Poway. And moving to Earth and Planetary Science, Evelyn Jeff, the Children's School. Annabelle Rojas Morgan, St. Michael's School, Poway. In engineering, electrical and mechanical, we have Finn Brentnall, St. Gregory the Great Catholic School. Chase Terry, Nativity School. Tyler Williams, St. Michael's School, Poway. In engineering, energy and transport, we have Santiago Martinez, Nazareth School. In engineering, materials and bioengineering, we have Jordan Romano from Mount Helix Academy. In Environmental Sciences and Management, we have Austin DeFrancia, St. Michael's School, Poway. Colin Dion from St. Peter the Apostle Catholic School. Zachary Eisenman from Swal San Diego Hebrew Day School. Bernardo Marche from Our Lady of Guadalupe Academy. Adrian Pham from Nazareth School. Samantha Rivera from Chula Vista Middle School. Sonria Reglian Samansky from Chula Vista Middle School. Christine Talaga from St. Gregory the Great Catholic School. Moving to mathematical sciences, we have Ariel Browdy from Swal San Diego Hebrew Day School. In medicine and health sciences, we have Nicholas Barias from St. Peter the Apostle Catholic School. Roman Francens from Nazareth School. Nadia Lamb from Our Lady of Guadalupe Academy. In microbiology, we have Charlize Emerson from Chula Vista Middle School. Lucas Mickelson and Sarah Mickelson from St. John's School, Encinitas. In physics and astronomy, Alexandra Colucci from St. John's School, Encinitas. Faith Duarte from Coastal Academy. Colin McPhail from St. John's School, Encinitas. Cassidy Moroka, Chula Vista Middle School. Lila Palechik from St. John's School, Encinitas. John Putras from Mount Helix Academy. And in plant sciences, Shira Adato from Swal San Diego Hebrew Day School. Cielo Muniz Sigala from Bonita Vista Middle School. Kate Tran from St. Michael's School, Poway. And that concludes the second awards in the junior division. So we'll move to the senior division. In the behavioral and social sciences category, we have Dana Bundogji, Bright Horizon Academy, 9 to 12. John Park, Canyon Crest Academy. Uma Sharma from Del Norte High School. Dasha Zerboni from Canyon Crest Academy. In biochemistry, we have Alejandro Berkowitz from Canyon Crest Academy. Pia Deluri from Canyon Crest Academy. Kate Wang from Canyon Crest Academy. In computer science, we have Pranav Bantval from Canyon Crest Academy. Arjun Chatha from Canyon Crest Academy. Nitin Chilakpati from Canyon Crest Academy. William Kong from Canyon Crest Academy. Maya Rosenbaum from Canyon Crest Academy. And in engineering, electrical and mechanical, we have Soleiman Al-Wazir from Bright Horizon Academy, 9 to 12. Francisco Catanzaro and Marcus Catanzaro from Cathedral Catholic High School. Manav Kanvilkar from Canyon Crest Academy. Mark Kuo from La Jolla High School. In engineering, materials and bioengineering, we have Ashton Anderson from Point Loma High School. Mert Kingcall from Del Norte High School. Gwenny Liu from Torrey Pines High School. Rahul Rao from Canyon Crest Academy. In environmental sciences and management, we have Abby Roman from Bonita Vista High School. Katie Wang and Lucia Wu from Canyon Crest Academy. Audrey Zhang from Del Norte High School. Moving to mathematical sciences, we have Sarah Benawal from Del Norte High School. Arkit Katurvedi from Canyon Crest Academy. Gavin McLarney from Canyon Crest Academy. Nivedita Rethnakar from Del Norte High School. On to medicine and health sciences. Morgan Feng from Westview High School. Kavya Gupta from Westview High School. Danya Hussein from Bright Horizon Academy, 9 to 12. Shukriya Osman from Bright Horizon Academy, 9 to 12. Nicole Su from Canyon Crest Academy. Andrew Zhang from Del Norte High School. Moving to microbiology, we have Emily Zhu from the Bishop School. And in physics and astronomy, Amy Barrett from Central Union High School. In plant sciences, Sarah Polyur from St. Joseph Academy, 9 to 12. And congratulations again to all of our second award winners. Give them a round of applause and hooray in the chat window in YouTube. And we will move to the first awards in this year's Greater San Diego Science and Engineering Fair, starting in the junior division with animal sciences. First awards go to Carlin Burns and Preston Bowe from St. John High School, Encinitas. Tanya Mondiam from Mesa Verde Middle School. And you can see additional awards that they qualified for down at the bottom there. So congratulations when you see those as well. John Roberts from St. Michael's School, Poway. In behavioral and social sciences, Sienna Bateman from the Children's School. Spencer Foss from San Diego Jewish Academy, 7 to 8. Rebecca Lehman from SWAL San Diego Hebrew Day School. Shane Montal from the Children's School. Ella Roberts from Bonita Vista Middle School. Melissa Soberanes from Our Lady of Guadalupe Academy. And Derek Wilson from St. Michael's School, Poway. Moving to biochemistry, Dhruv Bantval from Sage Canyon Elementary School. Sarah Gao from Pacific Trails Middle School. Hafsa Kazi from Bright Horizon Academy, 6 to 8. In chemistry, we have Cam Placencia from Chula Vista Middle School. In computer science, Arnav Dagar from Pacific Trails Middle School. Cole Guzlan from St. Gregory the Great Catholic School. Rohin Sood from Oak Valley Middle School. In computer sciences and product testing, we have Eyal Amsalem from SWAL San Diego Hebrew Day School. Charlotte Birch from City Tree Christian School, 6 to 8. Asha Brocious from the Children's School. Alexa Feliciano from St. Michael's School, Poway. Hadaria Levy from SWAL San Diego Hebrew Day School. Theodora Totolu from St. Michael's School, Poway. In Earth and Planetary Science, we have Neha Bhatt from Carmel Valley Middle School. In Engineering, Electrical and Mechanical, we have Ziad Ali from Bright Horizon Academy, 6 to 8. Aditya Bisain from Solana Ranch Elementary School. Isa Tim from the Children's School. In Engineering, Energy and Transport, Grace Cunningham, Nazareth School. Anirudh Kalyadaraman, there we go, Mesa Verde Middle School. In Engineering, Materials and Bioengineering, we have Charles Kraljevich and Kai Rogers from St. Michael's School, Poway. Elizabeth Paul from St. Michael's School, Poway. Aharon Pecos from SWAL San Diego Hebrew Day School. Kai Rogers and Charles Kraljevich from St. Michael's School, Poway. Kaylee Shu from the Bishop School. In Environmental Sciences and Management, we have Nate Aragante from Coastal Academy. Carter Jackson from Coastal Academy. Alyssa McWilliams from Thurgood Marshall Middle School. Alex Rotunda from St. Peter the Apostle Catholic School. Annie Verkoshi from St. Michael's School, Poway. In Mathematical Sciences, Logan Brown, High Tech Middle, North County. Siddharth Erat from Erat School. Nandana Madhukara from Pacific Trails Middle School. In medicine and health sciences, we have Francis Aguilar from St. Michael's School, Poway. Leanne Fan from Mesa Verde Middle School. William Gao from Pacific Trails Middle School. Emma Morin from City Tree Christian School, 6 to 8. Abigail Moriosef from Swall San Diego Hebrew Day School. Kate Shu from Oak Valley Middle School. In microbiology, we have Sanvi Dogra from Oak Valley Middle School. Sarah Youssef from Bright Horizon Academy, 6 to 8. Andres Zagurski from Swall San Diego Hebrew Day School. In physics and astronomy, we have Grace Balkowski from Nazareth School. Vikramaditya Siddharth Chandra from San Elijo Middle School. Charles Gorman from Classical Conversations. Micah Hall from Mount Helix Academy. In plant sciences, Faith Beltran from St. Gregory the Great Catholic School. Natalie Hernandez from Chula Vista Middle School. And that concludes the first awards in the junior division. So we will move to the first awards in the senior division, starting in behavioral and social sciences. We begin with Hari Krishnamurthy from Canyon Crest Academy. Anjana Sriram from Canyon Crest Academy. Mehar Thaper from Canyon Crest Academy. In biochemistry, Jesse Gann from San Diego Jewish Academy, 9 to 12. Manas Kumar Gantla from Canyon Crest Academy. Daniel Wang from Torrey Pines High School. In chemistry, Abigail Way from Canyon Crest Academy. In computer science, Rohit Day from Del Norte High School. Yash Gupta from Canyon Crest Academy. James Ho from the Bishop School. Ishan Kapoor from Del Norte High School. Ayush Nayak from Westview High School. Annabelle Ng, Westview High School. Nitya Pillai from Del Norte High School. Rajdeep Singh from Canyon Crest Academy. Edmund Sumpena from Westview High School. Amy Shu from Canyon Crest Academy. And I think we switched into computer science there. I may not have mentioned that. Moving to engineering, electrical and mechanical. Jimmy Fang, Torrey Pines High School. Jessica McWilliams, Scripps Ranch High School. Michael Zhang from the Bishop School. Moving to engineering, energy, and transport. Bella Rose Schremer from University City High School. In engineering, materials, and bioengineering, we have Kara Fan, Westview High School. Kyle Tianchi, the Cambridge School High School. Lindsay Wright, Del Norte High School. In environmental sciences and management, we have Ayush Agrawal, Canyon Crest Academy. Nathan Dye from Canyon Crest Academy. In mathematical sciences, Benjamin Factor from Canyon Crest Academy. Agastya Sridharan from Scripps Ranch High School. Christopher from Torrey Pines High School. In medicine and health sciences, Neha Dandu from Canyon Crest Academy. Andrew Gao from Canyon Crest Academy. Ryan Wang from Canyon Crest Academy. Chris Jung from Canyon Crest Academy. Eric Lee from the Bishop School. Atulya Mandyam from Westview High School. Badra Rupesh from the Bishop School. Srinidhi Surineni from Canyon Crest Academy. Jason Tang from Canyon Crest Academy. And Akarsh Vermani from Westview High School. One more, Ellen Shu from Medicine and Health Sciences in Del Norte High School. And Shirley Shu from the Bishop School. Another one, Wanya Zhu from Canyon Crest Academy. Scared you for a moment there that we were done with medicine and health sciences. Now I think we're moving on to microbiology. The first awards in senior division go to Elaine Dong, Canyon Crest Academy. Eleanor Jung, Mount Carmel High School. In physics and astronomy, we have Ryan Claremont, Canyon Crest Academy. Andrew Lee, Canyon Crest Academy. Vivek Vijayakumar, San Marcos High School. In plant sciences, Diego Nunez, Bonita Vista High School. Suvali Sengupta, Westview High School. Congratulations to all of our first award winners. Give them a big round of applause in the YouTube chat there. And with that, I am going to exit here and hand back to Mr. Rodeker.
And thank you, Dr. Williams. As you saw in the first place award slides, the top projects from among the first place winners have been invited to the California Science and Engineering Fair. GSDSEF has been allotted 89 spaces in this year's California Science and Engineering Fair. Again, if you are a CSEF qualified student, you will receive information from us about applying. In addition, the Broadcom Masters Contest from the Society for Science is providing 28 entry packets for 6th, 7th, and 8th graders from our fair. Broadcom Masters nominated students will be contacted. The names and information will also be posted on the GSDSEF website. That concludes the place awards, and let's give all the winners recognition. In YouTube, use the chat box to show your appreciation. And now it is time to announce the grand awards, which will be done in the following order. The 4 Junior Division Grand Award runners-up, the 4 Senior Division Grand Award runners-up, the 4 Junior Division Grand Award winners, and finally, the 4 Senior Division Grand Award winners and ISEF, International Science and Engineering Fair trip winners. Junior and Senior Division Grand Award runners-up receive a plaque and a check. And Dr. Williams, you have the honors again.
All right, so on to the Grand Awards runners-up. In Junior Division, the Grand Award runner-up in Life Sciences is William Gao from Pacific Trails Middle School, grade 7. Advisor S. Thacker, finding non-invasive pancreatic cancer microRNA biomarkers. Congratulations, William. The next Grand Award runner-up in Life Sciences is Sarah Gao from Pacific Trails Middle School, grade 8. Her advisor S. Thacker, finding inhibitors of bacterial efflux pump proteins. Congratulations, Sarah. The Grand Award runner-up first in Physical Sciences is Neha Bhatt from Carmel Valley Middle School, grade 8. Advisor N. Klum, using Google Earth Engine to identify California gnatcatcher habitats. And the second Grand Award runner-up in Physical Sciences goes to Isa Tim, the Children's School, grade 8. Advisor D. Quincannon, designing a bicycle-powered charging system. Moving now to our Senior Division Grand Awards runners-up. First in Life Sciences, the first Grand Award runner-up is Eleanor Jung, Mount Carmel High School, grade 10. Advisor A. Klingborg. Molecular dynamics simulation of novel Klebsiella pneumoniae treatment, disrupting the outer membrane. The second Grand Award runner-up in Life Sciences is Kara Fan, Westview High School, grade 10. Advisor S. Hollander, dragonflies beet infection, fabrication of antibacterial nanostructures for orthopedic implants. Moving to our Grand Award runner-up in Physical Sciences, first is Andrew Lee, Canyon Crest Academy, grade 10. Advisor W. Slake, the age of the Coma Bear cluster constrained using amateur data. And the second Grand Award runner-up in physical sciences is James Ho, the Bishop School, grade 10. Advisor M. Jakelin. Probabilistic approach to analyzing racial bias in BERT on an attribute basis. Moving next to the Taiwan Award. And with this, I'm checking here, I believe I would like now to announce the Taiwan Award, which is a grand award in the Greater San Diego Science and Engineering Fair, given each year by the Taiwanese American Foundation of San Diego. This award includes a $2,000 check and a certificate to be awarded later. And the winner of the Taiwan Award in 2021 is Kara Fan, Westview High School, grade 10. Advisor S. Hollander, dragonflies beet infection, fabrication of antibacterial nanostructures for orthopedic implants. And now, the Grand Awards. Each Junior Division Grand Award winner will receive a plaque and a check. In the Junior Division, the Grand Award winners in the Life Sciences are Kara Fan, Westview High School. Oh, that's Taiwan Award. Let me try that again here. Here we go. Leanne Fan, Mesa Verde Middle School, grade 7. Advisor Jay Wu, controlling middle ear infection using photodynamic therapy. And Kate Shu, Oak Valley Middle School, grade 8. Advisor Kay Smith, identifying patterns in Kawasaki disease patients through data analysis and visualization. Moving next to our Grand Award in the Junior Division in Physical Sciences, Siddharth Erat from Erat School, grade 8, Advisor S. Erat, Colonel Blotto game, and analysis and extensions to networks. And the second Grand Award in Physical Sciences in the Junior Division goes to Arnav Dagar, Pacific Trails Middle School, grade 7, Advisor K. Chen, a study of AI agents for two-player games. And now, the 2021 Senior Division projects that have been selected for the Grand Awards. These winners will receive plaques and the opportunity to compete in the 2021 Virtual Intel International Science and Engineering Fair, where they will compete for additional awards with science fair winners from 50 states and 78 countries. And each ISEF student will receive a $1,000 scholarship from the Greater San Diego Science and Engineering Fair. The 2021 Senior Division Grand Award winners in the Life Sciences are Ellen Shu, Del Norte High School, grade 10, Advisor A. Calicott, developing a robust deep ensemble network for Kawasaki disease early diagnosis. And Ayush Agrawal, Canyon Crest Academy, grade 11, early warning detection of arsenic contamination from hyperspectral remote sensing and deep learning, an application to Asia. Moving to the Physical Sciences, the 2021 Senior Division Grand Award winners are Ryan Claremont, Canyon Crest Academy, grade 11, Advisor W. Slike, morphokinematic and hydrodynamic modeling of the Cat's Eye Nebula. And Kyle Tianchi, the Cambridge School, grade 9, Advisor M. Main, Nereid, nanoparticle examining Raspberry Pi empowered image processing detector. Best backronym of the night. All right, congratulations to all of our Grand Award winners going to ISEF in May. And back to you, Steve.
And Dr. Williams, thank you so much. And now, in the words of Tim Cook, and first of all, we're going to see the ISEF finalists, and here they are. But there's one more thing. This year, ISEF invited us to send 6 students to the International Science and Engineering Fair. So we are able to send 2 additional students, the Grand Award top runners-up in Life Science and Physical Science. Congratulations to Eleanor Jung and Andrew Lee, who will also be attending the virtual ISEF this year. Congratulations to you and our other 4 ISEF finalists. You are invited to participate in the virtual ISEF in May 2021, and I will be contacting you about participating. Let me remind all professional society award winners that their professional societies will be contacting them about their awards. Congratulations to all of our winners. And that concludes this year's award ceremony. Congratulations to you all for a magnificent job this year.